So here we're going to talk about all the things about mestrenova. And the first thing that we need to do is get it installed on your computer. So if you go to the website argenta2.rd.unr.edu, and you'll get the department's web server. Now you need to be on campus to access this. You can't do it from home. And you just go to number 7 here as mestrenova, and you're going to download the software. And you can download this for PC, Mac, or Windows, but not for a Chromebook or any other operating system. And our license only covers up to 12.0.4, so don't install the latest and greatest. Just install that. Then you're going to download the license file. Don't unzip it, just download the file. And then when you launch it, it's going to ask you for where you stored that downloaded file. And I usually just store it in documents. And from there, you should be able to. But you need to be on the chemistry department network to activate that license. Actually, you need to be on the campus network to activate the license. And once you do that, you'll check out a license that's good for 3 months. And then after that, you need to renew it. And you need to be on the plugged into a wall, not on the campus wireless. So if your laptop does not have a Ethernet port, but just USB, then come to 011 and ask me to help you out with that, because I have some adapters that will allow you to go USB to Ethernet. Then after that, you can access your data when you're plugged into the wall of the chemistry building or somewhere on campus. And for Macs, it's fairly simple. You just go to Go Network, and you should see Argenta 2 there, like on my computer here. There's Argenta 2 right there. It'll just pop up. For Windows, you need to map the network drive, and that usually means going to your computer and finding My Computer on your computer. Right click on it and then type in map network drive as an option. And then you're going to paste this line in there and make sure reconnect.login is checked. And that should allow you to access the data from Windows. Again, if you have trouble with this, come in to 011 and see me about it. So once you have mestrenova on your computer, you should be able to launch it with no errors. And if you go to help and then license manager, you should see that NMR has got some negative values here. And that means it's all installed. And at that point, you can open the data by just clicking on this open icon, open folder, and you're going to go to wherever you stored your data. And usually that's under your boss than you. So if you worked for like Professor Shalafu, and let's say we'll pick Paban here, and hopefully, yep, he's got a lot of data here. And each one represents an NMR experiment that he saved. And you just double click on one and you open up the FID file. And there is a spectrum. And let me find another one here. So we're going to open up a couple here. So I find one that I like. Let's try this one here. That one's okay. Let's open up another one. Let's find somebody else. There's another one. We're just going to open up. Let's try find one in my folder. So MR. And there we go. Let's see. Walmart olive oil. Let's look at that one. Okay, we'll just use this Walmart olive oil one. And the first thing that you do after you open it up is you're going to want to process your NMR data. And like like I said, the first thing that you're going to do is phase a spectrum. And this one doesn't really have a phase error. And a phase error will look something like this. Sometimes you'll see this in your 1Ds and 2Ds NMR where the baseline around your peak is not symmetrical. And to fix it, you just grab this one. It looks like a little out of phase peak, and you just go to manual correction. And you're going to either left mouse or right mouse drag in this purple box until it looks okay. And it's a cosmetic thing, so just going to make it as symmetrical as you can around the base of the peak. And so that's phasing it. Now, the next step after you've got it nicely phased is to reference the data. And so you want to ensure that the x-axis here is correct. And by definition, we use trimethylsilane, or TMS, as our reference point. We call that 0 in proton and 0 in carbon. And so the software will usually grab that for you. So I'm going to zoom in around 0 and kind of make the peak a little bigger. And this point should be 0. But if you want to force it to 0, you grab this one. It looks like an arrow pointing to the top of a peak. And you just click on reference. You mouse over the peak, it glows red, and you click. And now you just type in 0. And now that peak is exactly at 0. Now if your baseline is a little bit shifted up or high, you can just grab this little hand guy right here and pull it down. There you go. And now it looks a little bit better. So we did referencing, and then we did the phase correction also. Now sometimes you don't have TMS, say like in this peak here, this spectrum here, whatever, for some reason they didn't have TMS. And if you want to see what they did it in, you just go View at the main menu bar, and then you select Tables, and then Parameters, and click OK. And this says that they did it in chloroform. Now you're just going to have to know, there's some tables in the NMR room that tell you what the chemical shift of chloroform is in deuterated chloroform. And it's down here around 7.26. And so this is it right here. This should be a singlet. This is a badly shimmed spectrum. And so what you can do if it didn't have TMS is you just go back to that reference one, click on the peak, go to solvents, and then go down to chloroform. Click on it, and it transfers up 7.26, and you go OK. And that makes that point the reference point. You do that if you don't have any TMS. And so that's this regular chloroform and deuterated chloroform, that's called the residual solvent proton. And every deuterated solvent has that. And there's big tables of it in the NMR room, but it's also the tables are built into the mestrenova software. After you've done the referencing, the next step is we're going to do integration. So integration is finding the area under the peaks, because the area is proportional to the number of protons. And so how you do integration is you just look at this one. It looks like a sort of a calculus integral symbol, and you select manual. And you just drag from somewhere flat near the baseline of a peak to somewhere flat. And the first time you drag across something, it'll just call it by default 1. But we could grab something else. This one here, and this one here. And generally you want to integrate everything except for your solvent peak, your residual solvent proton. Or you generally want to integrate your TMS peak or something. That's not part of your compound system. But if you wanted to set this to a specific number of protons, any one of them, you just mouse over it till it turns this sort of salmon pink color, and then you right click and go Edit Integral. And you can say, well, I made this and I know it's 3 protons. And so that updates that to 3 and everybody else's values 2. And if you want to see a table of this, you just go to View, again, Tables, and then you go down to NMR and you want the integrals. And this generates a table that you can copy and paste into other places. The next step is if you want to, say, label the peaks with their chemical shifts. Let's just pick this one right here. And so you go to this one, it looks like a hand grabbing the top of a peak, and you just go peak by peak. And then you just mouse over and click, and wherever you click, it adds a label. And so you get the chemical shift of each peak. Again, if you want to see it, you just go to View, Tables, under NMR, just select Peaks, and say OK, and that gives you a table. There's a couple of important things when you're doing NMR. One is to see if the shimming was good. And shimming is, we do shimming to make the magnetic field uniform around your sample. And when your shimming is well, or good, your TMS peak should be a sharp singlet. Okay, it shouldn't be split. Now you can tell here this is not good shimming because it's a singlet, but there's also a little splitting here and some little splitting here. It's fairly sharp though, but the shimming is not the greatest. And so you can measure it a couple of different ways. One is just grab the crosshairs here, and you see the peak is 143, so about 0.7 will be the width at half height. So somewhere down here, and you get a peak width around 3.3 hertz. That sounds a bit large. But you could also do the peak picking, and then go to View, oops, wrong thing. View Tables, and then go to Peaks. And you can see the width is 166. That looks like more of half height right there. I must have misgauged it. I would say, half height is right here. 166. I don't know where they're getting that. Yeah, I think they're picking somewhere here. When it's got these extra little bumps in it, it's kind of hard to figure out. But it's not a good peak. I would have picked somewhere around here and said, okay, it's about 1.53 hertz, the width at half height. Now, for a well-shim system, you want the peak width to be less than 1 hertz at a half height, and you want it to be a nice sharp singlet. So if it isn't, then you need to either rerun your sample to reshim it, or you need to filter your sample or add more sample to it. If you have too little of a sample, you get some bad shimming too. And so that's something that you should always check on every spectrum that you get, is make sure that your TMS peak is a sharp singlet that is less than a hertz, 1 hertz width at half height. And this spectrum has got some weird thing going on. Let me try a process. Do a baseline correction on it. Oh, I think I'm going the wrong way. Yeah, I think I messed it up a little bit too much doing all these baseline shifts. Okay, now it looks a little better. There we go. So that was just a baseline correction under the processing menu. Okay, and so we did the measuring the TMS, but another thing that you might want to do is measure coupling constants. And say for this doublet here, you wanted to know the coupling constant. You just grab the crosshairs, take it from the top of one peak to the top of another peak. And so that tells you that it's 4.28 hertz is the coupling constant. So that's an easy way to do it. Now, pretty much everything in mestrenova is customizable. You just see your whole spectrum. You right-click on it when it's selecting, select Properties, and say you wanted your spectrum to be red or something. And you can make it red. And you can change the font size, colors, and everything. And you can save it too. You could say, save into your documents, my poster settings, and say, okay. Now, if you went back to your default, say of your spectrum being black or something like that, and then say you had all your poster settings, you could just recall it. Open my poster settings, apply it, and now it's memorized everything that you've ever changed for making your own custom poster settings. Another useful thing that I show most people is we can create a new page here by right-selecting it, and then we could go over to say ChemDraw here and draw out something. And this is good for just checking your structure or analyzing some unknowns. Whoops. Let's see if I draw out something weird here. And let's let's just leave it like that. Come on, get rid of it. Let's see, what if we try this? There we go. Maybe my O didn't go to the right spot. Let's try again here. Alright, I think that's okay. Let's try object. Let's see, structure, clean up structure. Yes, for some reason my oxygen is not going on the right spot here. Let me try again. There we go. Structure, clean up structure. Alright, then we can just copy this into mestrenova, then go to Predict menu, and then say Proton Spectrum. And now we have it. If you could mouse over, mouse over each one, say the methyl group here, and it tells you where it should be, what its multiplicity is. And so it's a good way to check it if you don't want to look it up in tables and everything else where everything should be. And you say, what's number 2? Well, that's that one right here. So it's a nice little convenient feature. And you have some annotation features down here at the bottom too. Say if you want to draw, say, an arrow, and say, let's see, text. What is this? And there you go. Let's move this guy over. And so that's the basics for processing in mestrenova. The benefit of mestrenova is that you can process it. Now you can save your process data. You can copy the whole everything, and then open up, say, PowerPoint here. Let's see if I have it. Oh, that's documents. We want applications. And let's see, I should have PowerPoint in here somewhere. There we go. Just do a blank presentation. And we just paste it. And now we have our NMR spectrum inside of PowerPoint, and we could add other things or make a presentation out of it as needed. So that's the basics of using Mestrenova.